or?
Someone left.
Okay. How many are left yet?
4 to 5%.
4 to 5. Right. So can you please send them messages? We can wait for them as well.
Yes, ma'am.
Yes. Okay, hi, good evening. I am Shruti. So we'll be seeing database management system. I assume everyone has joined. Like, are there anybody missing?
Almost all joined.
Okay, fine. Okay, then let's proceed. So, database management system, Dbms, as you all know. So, it is a part of paper 3, which is asked along with climatology, statistics, and agromet. So, it's for 7 marks, and it's pretty simple subject. So, we will be seeing more on this today. Okay, today and tomorrow, 2 classes will be there. And before we proceed, I would like to know, like, how many of you are actually familiar with this? Like, is that like most of you are from computer science, the background or physics background, are like, do you know about database? Something, some basics?
Yes.
Yes. You can also send and checking the message all as well. So you know, Saurabh Chand knows basics, right?
Yes, ma'am.
Okay, cool. So this is like for 7 marks, and the subject is also pretty basic only. But still, from the exam point of view, we will see how to like what are all other important steps. Okay. Still, though you seem to know, I'll just start off with the basic definitions because they seem to ask such questions in the exam. Okay. Please mute, and in case of doubt, you can just send the message, or you can even interrupt in between and ask, no problem. But I'll just keep on going, okay? So we'll start off with the basic definitions. What is data, information, knowledge? Data is like raw facts, like unprocessed fact. That's all. Like for example, you have 27 degrees Celsius, 65% humidity, but you just have the facts, you just have the figures, and no information about it. And then when you process the data, actually, then there comes the information. Okay, the data that has been organized or processed. For example, the temperature is 27 degree and the humidity is 65%. And whatever you gather, whatever you understand from the information is what you call as knowledge. For example, since the humidity is high and the temperature is also 27 degree, you might feel uncomfortable outside. So this is called as knowledge. So this is one such question which has been asked before. So you can just write down, if they ask this question. Okay. And again, so you know what is data is, and then we move on to database. So the collection of related data. For example, you have a library database which needs to have data about the book, its author, and who all have borrowed that book. So that is called as a database. You have a collection of data which is related, and it is arranged for ease and speed of search. And who is a database administrator? So if there is a database, and there should be somebody who should give access to the database. Right? Everybody can't access, and if that happens, that will be a problem, that will be an issue. So a person who is responsible for authorizing the access to the database, coordinating and monitoring it is called as a database administrator. And who is known as a database designer? And if you need to have a database, it should be efficient. Like you just can't put every data in any order that you want. It should be organized in such a way so that the data is stored in an efficient way. So the team or a person who is usually a professional who designs the database who decides how the database should be is a database designer. Right? Are you still with me?
Yes, ma'am.
Yes, ma'am.
Okay. And then, so you have data, you have database, and initially how the system was. Now you have database management system, but before it, the old one is the file management system. So before databases became common, we were using storing and organizing the data in files. For example, you have text files, CSV files. Usually we call that as a flat file, whatever we see now. So again, I will explain this with an example. You have a school database. So for student, you will have a file, and then for whatever the score they have, you will have a file, and then for attendance, you will have a file. Students, you can have save for example, if you save the student file as a text file, in which we open with using a notepad. And the scores you have a CSV file. So different kinds of file will be there, and you can't relate them. You can't find a relationship between the files like a notepad and Excel file. You have to open a notepad separately. You have to open a CSV separately. So this doesn't seem to be an efficient way, right? So that's why this we have come up with a database management system. So as you can see, there will be drawbacks for this file management system. This is a very usually asked question: what is a file management system? What are the drawbacks? So I just put on whatever that can be written. You can even elaborate this more and write. So it is very self-explanatory, but still I'll explain you. If you have a file management system, it means that you will have the same data again and again. You have a student database where you have student detail, and then you will have the same detail again in a score file. So if that is going to be there, it means that you have the same data in multiple files. So that will lead to redundancy and inconsistency. And data isolation, like you have data scattered around various files in different format, and that is also not a very good problem. I mean, good situation or a good attribute for a management system. And then you have to depend on an application program. For example, you need a Excel to open a CSV file, and you have to be dependent on an application program. And so that would also be difficult. And then atomicity issue. Atomicity means like this: the tagline is like all or nothing. So I'll explain more about this later. But for now, if you start a transaction, it should get completed. It should not like stop in between. So that issue is possible in a file management system. And the data security. So you can't efficiently manage who will access the file. So it leads to security breach. And then backup and recovery, you need to take manually the backup. It doesn't say gets backed up automatically. And scalability issue: as data grows, performance degrades. So it becomes difficult and inefficient. So these are the most common drawbacks for the file management system. And this is asked in exam usually. Okay. So we came up with the Dbms, that is the database management system. So we know what data is, what database is. So now we need a system to manage the database. So we have to create, manage, and manipulate, that is, update the database basically. So the software that allows us to do all these things efficiently is called as a database management system. So it has a systematic way to store, retrieve, and organize the data. Okay, so majorly what are the benefits of it? So it ensures security, integrity, and consistency. So if I'll again explain you with an example. For security, like I've explained you who is a database administrator, right? So when you have an administrator, then not everybody can access the database, and not everybody can delete the student record. So this in turn gives us the security and integrity. Integrity, as in, for this, if you take this example, age cannot be a negative number, right? And you can give this as a constraint when you develop a database management system, and you have a constraint as that age should be positive number. So in such way, you will maintain the integrity of the database. And then the consistency. So if a student is transferred from one department to the another department, then both the student department information and student count should be updated. Two separate tables should be updated. Consistency, because if one is updated and another is not updated, if it happens in case of file management system, it will lead to inconsistency. So while we use the Dbms, we will ensure that security, integrity, and consistency is being maintained. Okay. So, I still have all of you with me, or do you have any doubt? Are you guys sleeping?
No, ma'am.
All right, I don't hear any other voice other than Saurabh. Are there any other? You are listening, right? If you feel sleepy, tell me, or if you have any question, also tell me. No problem. Please don't sleep. Okay. Okay. Is my screen visible? Can you see the slide?
Yes, ma'am.
Okay. So this database management system provides you with DDL, three kinds of languages. Okay, data definition language, data manipulation language, and data control language. So we basically DDL helps you to create a table. It will help you to define how the table should be, how many records should be, how many columns should be. So, and manipulation language will help you to insert the data, actual data, student data, or whatever you want to insert, update, or delete. You can do it with the help of DML. Data control language helps us to regulate the access of the data. So these three kinds of languages are there. And then also data dictionary. This can also be our data dictionary is like a map or index of the database. It is called as metadata. Typically, the definition for metadata is data about database. It's like you have a table and again a student information table. So how the table will be, how many tables are there, how many columns are there, what is the data that is being, what is the type of data that is stored, such kind of information. And the index to the database is called as a metadata. They usually ask what metadata is, what data dictionary is, so that is also important. So we have there are some properties for a database which helps in maintaining the integrity, okay, during a transaction, and it is shortly called as ACID property, which stands for atomicity, consistency, isolation, and durability. So as I mentioned, atomicity I mentioned before as a disadvantage to the file management system. Atomicity, it is like all or nothing. The transaction must be fully completed or it should not happen at all. So if you have an ATM transaction or if you take any money transfer, money must be debited, right? And it should be credited. If one part fails, if you do a transaction, if the amount gets debited from your account, but it is not credited to the other person's account, then it is a failed transaction. So a proper database management system should ensure that this does not happen. So this property is called as atomicity. The next one is consistency. So the data, like it must remain correct and valid before and after the transaction. So you have a constraint, like you maintain a constraint for a database that if a rule says that account balance can't go negative, then the rule must hold after the transaction as well. So it will not let you to make the transaction because it will go to negative balance. So the transaction should not happen. So this is called as consistency. The third property is isolation. So transactions, even if there are multiple transactions that are happening, each transaction should happen as if like they are happening independently. Okay, even if they are happening in the same time. Intermediate results should not interfere with each other. So if two persons are booking movie ticket, say only one should succeed. Okay, the process of one should not interrupt the transaction of the other one. And then durability. The last one is durability. So once the transaction is done, the result is permanent, even if the system crashes. So after you say again, if you book a ticket, if you have booked, even if the system crashes, your booking should still remain intact. So it is called as durability. So we have to, while having a database management system, we have to ensure that all these four properties, atomicity, consistency, isolation, and durability should be managed. Okay? Understood? Is there any doubt? Do you have any doubt?
No, ma'am.
No? Okay. So DBMS architecture, I'll have your attention because this is also an important question like file management system. They ask this. You can see it in previous year question papers. So DBMS architecture is like how how the system is going to be, how the database is going to be managed. So the structure and design used to build the software that stores and manages the data. So it tells how the component, like how the user, server, database, different components of the system, how are they organized and how are they connected is what we can understand from the DBMS architecture. One such type of architecture can be from the setup, like centralized, decentralized, and hierarchical. Centralized as in everything will be in one system, and decentralized multiple system. It as you can understand from the word, multiple systems will be there, but they will be still connected to each other. Hierarchical, there will be one system at the top, and you will have a tree-like structure, and the data will be arranged accordingly. Another type of architecture, the most common, is like based on tiers. It's like you have one tier architecture, two tier, three tier, and n tier. So one tier architecture is something like every one tier, like there will be only one machine. So the database, the user interface, and the application logic, everything will be in one machine. So it is not secure, it is not scalable, but still it's simple. So when you need the application is very simple or your user is very simple, straightforward, then we can go for this type of architecture, like using Microsoft Access. And if any of you have used Access, you will be knowing. Then you'll have a database in it, you'll have an interface, everything will be there. But how much amount of data it can handle, it will be very limited compared to the most advanced system. So this basically sums up what one tier architecture is. The next is two-tier architecture. It will have a client server model. So two layers as mentioned. It will have a client, that is the user interface, where what we see in the like front end is what we call as the user interface. And there will be a server, the database, where whatever we need to access will be there. So only two layers will be there. It is definitely better than one tier, but it can also get overloaded when you have multiple users. So this directly communicate with the server. So you have an interface, you have a server, so the client can directly access the database. And an example is like you have a central database and there are many desktop which is connected. Then a desktop application accessing the central database can be an example for two-tier architecture. The third one is a three-tier architecture, which is a very most common because of its advantage that it is whatever we've seen before, that it is not scalable, it is not secure, it can get overloaded. These kind of disadvantage of the previously seen architecture is has been dealt by this three-tier architecture. It is scalable, it is secure, and it is efficient. Okay, so we have, what is the difference? You have a presentation layer and user interface layer is there, and a data layer which has a database is also there. In between, you have an application layer, which is a middleware, a logic or a processing. Usually, we call it as a logic. So three layers will be there, and it is more efficient than one tier or two tier architecture. So example, if you take a website like Amazon, you have a website, and in the back end you will have a database where whatever data they have is stored, and you have a logic in the middle which runs on the server, and you will be able to access it. So this is a secure and efficient architecture. But if you have more advanced data, you have more amount of data, then you will have to scale up. So in that case, we have n tier. N tier can be anything, like n can be any number, more than three layers basically. So we have like modules. Modules assist each system will act as a module, and each one can be updated and replaced independently. That is the main advantage. If one system gets crashed, and it doesn't mean that the entire architecture will collapse, because by removing that particular module you can still move on, you can still continue the system efficiently. So where this should be used when your application is complicated, when you have a large enterprise system or cloud based application, you will have to go with an n-tier architecture. So when you have a simple usage, you go with one tier architecture, and two tier when you don't have multiple user, three tier when you have like most commonly used, and n tier when you're going to use it for a large enterprise system. Understood?
Yes, ma'am.
Yes, ma'am.
Any doubt or anything I can? I can give you a couple of minutes if you want. I'll move on to the next slide. So we've seen, I'll just scroll up and see we saw data, and then we saw what database is, we saw what a database management system is, and then we will move to database system. Okay, database system will have database and the database management system, and then applications that interact with it. So you'll be able to understand this better if you can understand this banking example. So you have an online banking system. Okay, so we will have database for the banking, and you'll have a Dbms, and you'll have an application. What is the database? What does the database basically has? It stores the customer details, account balance, transaction, loan accounts, whatever it is, whatever the data which what the banking will have will be stored in a database. And you have the database, now you have to manage it, so you will need a database management system. Like usually it is a software, not usually, it is always a software like Oracle or MySQL, which will manage the data. So database, and then the DBMS, and then the application. So you have an Axis Bank application, SBI Bank application, whatever it is, the bank application app or a website that the customer uses to check the balance, transfer money, and pay the bill. So this whole three components constitute to a database system. Okay. And if you want to write it in the exam, you can use this diagram, a typical diagram where you have a customer database and you have a database management system, and you will have multiple applications like programs, checking account program, saving account program, installment program. So programs that will be running, and when you need to inquiry, you can access the management system, and which in turn access the database, and you will have checking account data, savings account data, or whatever data that you need from the system. So the usual question is like, what is a file system? We saw, and then what is the disadvantage of the file system? And then you came up with the DBMS. Now you have to explain why we need DBMS over a file system. This is also asked. So whatever the disadvantage we saw in the file system will be an advantage of the DBMS system. That will be more like rectified, and that's why we have a new system. So there are no redundant data, as in. Database, like you have a separate tables, right? So same information will not be available again and again in different files as in the file system. So there will be the data will be consistent, and integrity, as I've said, you can maintain constraint like then balance should not be negative, age should not be negative, name can't be number. That kind of by maintaining this such kind of constraint, you will have a good integrity maintained database. And then data security, you have a bank account, you don't want everybody to access your details, so you have a database administrator who will ensure that your security and your privacy is being maintained. And then easy access of data, as in even if you have something very complicated which needs to access 2, 3, 5 or whatever number of table, you will be able to do with the help of a DBMS software. Like you can have, that's why you have languages, the data definition languages or data manipulation languages. You can use a query like SQL query, and you can access the data like a student who is of this class and who is of this height, what is his where is he from. If you want you have multiple conditions, if you want data of multiple conditions, you will be able to easily access it and easily recover it. As I mentioned in the file system, you have to manually backup it every time, but when it comes to database management system, automatically backup happens, and even if there is a crash, your data will still be there will be a backup, and the recovery of the data in case of failure is still possible. Flexible, it is more flexible than file processing system because you can add more number of data. It is scalable. You can increase whatever you want. So in that way, we can say that it is flexible. Okay. And I still have more to write. Who is it? Why are you coughing?
In charge is there.
Okay, so have you guys understood or till now? Is it okay?
Yes, ma'am.
Yes,
So
ma'am.
you have these are the questions, right? I've got the PPT like in the way of a questions only, question and answers only. So you understand them, and so that you will be able to write it in the exam. And these are the foundation concepts of how a database will be. Uh, I'll just explain it one by one. This is how it looks like. Okay, you take a table. I'll explain how they call this table, like different parts of the table, how they call. So, entity is like a person or a place or object or an event. Okay, so entity, for example, is a student, or if you have in a library database, a book. So, a person or a place is called as an entity. It is stored in a row, table row. An attribute is characteristic of that person. So you have a student, and age is one of the characteristics of character of the student. So age or what department he belongs to, what is his name, that is what we call as an attribute. And what is called as a record? Record is like a collection of field, a table row. A single row in a table is called as a record. And field, it is the column of the table. Okay, so you have a record, you have a field, together they will make table. So related record, collection of related records is called as table, like student table, which will have collection of student records. And a database is a collection of related table. The whole student management system with multiple related tables, student table, course table, mark table is what we call as a database. So you see this diagram for better understanding. So here we have like this one, right? So each one is an entity. Each one is a row. Like this whole thing, this row is what we called as a record. Can you see record? Okay, and then you have different columns, right? Agent code, agent name, working area. These are columns is what we usually call, and here we call it as a field. So row or record is same, column or field is same. So and then you have column name. This whole thing is called as a table, and you have a key field. Key field is something which you use for identification, a unique number. We have an Aadhaar number, right? Like which is not same for any two person. That is called as a key field. It should one record should be different from another record. What differentiate this from this is called as a key field. So you have entity, you have attribute, and then you will have a record and field. Together, record and field will create a table, and many table will create a database. This is like from here, like this is the basic, and this is the what we get database. So does database mean only it will have from for now you should be understanding like you have data, it is arranged in a specific way which is very easy to manage in tables and row, and then so does that mean that database will only have tables? Database is not just a bunch of tables. There will be relationship between them. As in, okay, you take this example. There is an order table, there is a customer table, and there is a product table. So standalone, there are table, and there is a relationship between them, right? Customer will place order. Will so you need the number, order number, customer, and then order will directly represent what is the product that they have created, right? So that is what you will have. Okay, so for example, you can also have it like you can also imagine student table. You will have a student table. You will have a mark table. You will have a address table. So if you want to know the person who have scored more mark, you want to know the address of the student who have like scored mark, you will have to access all these three tables which are interrelated. So there is a relationship between them. Okay, understood? Right.
Yes, ma'am.
So Are there any doubts? We still have some time left. If you have any doubts, you can ask. There is like some more which I'll continue tomorrow. But I just want to make sure you understood the basics. So if in case you have any doubt, you can ask me. Right, Pranav has left already. He is very clear, I think. So, are everybody clear here also? Okay, then let's end. Okay, we'll see you tomorrow.
Thank you, ma'am.
Thank
Thank you, ma'am.
you.